So we're going to go to the Fancy Pantsy program. We already have it open. The exit preview mode. So here's my 1-inch cube. I already set everything up to the M3D. I've actually got this program running on here, but lately it has not been wanting to cooperate with me. Might be the fact that I was found on a flash drive randomly.
Now, what program is this?
This is called Simplify 3D. This is a program that you could buy online for about $100. And the best part about it, you go to Help and you go to Configuration Assistant. You get to select every single printer that is out there. So you can use this one software for every single printer. And then you could obviously customize your own printer if you want to. So you gotta start new. You import, let's go back to that 1-inch cube. Now we can actually go into the processes and actually talk more about this one has a lot more things you could do with your slicing program. Obviously you want to choose PLA or ABS. And now here you could pick if you want to have it automatically do everything for you. Usually with the M3D already comes with its own program. Here's the M3D software. If you want to print, it only gives you 3 settings. But you can also go into the advanced and bring in the settings from these programs, which is more preferred. So here we have the extruder. We have its basic dimensions. We have nozzle size, which is the 0.4 millimeter. Extrusion multiplier, which is for tweaking if there's errors. Extrusion width is obviously the diameter of the head. Here we have the retraction. Retraction is very important if you have multiple parts. And I'm still trying to nail the numbers to exactly how I would like it for my printer. Here we have the layer height of your part. So usually standard layer height will be 0.2 millimeters. And here you could pick your top, bottom, and then you could choose more options like, do you want to have your infill printed before your outer perimeter, or do you want your outer printer printed before your infill? I would always recommend doing your drawing the lines, so you'll want to make your lines first. This is so you don't have any bubbling on the ends. If there's extra filament, gives a nice, once again, nicer surface finish. That's what everything always matters in the end. Is the part look good? We have additions here. We have more settings for the brim or for raft. Info percentage, here's showing your angle of your infill. You could also manipulate these. You could do 30, 60, 90, all the way around, have a circle type of deal. You can also change your pattern. I use the rectilinear, which is a zigzag pattern, but you could choose a grid, triangle, the honeycomb. Now here's some more support. So I will bring in apart the rocket into here and I'll show you how it builds up the support, what it looks like. So here's, if we want to support, we generate and go through all of the options for it.
So just to clarify, Justin, this support, so if you have some object that you want to print that has parts that overhang, that hang in free space, with this program you can automatically generate support structures for it?
This program will automatically generate the support structures for any overhang to the angle that you desire.
I'm guessing that feature is not in the other one?
It is in the other one, but
okay.
it doesn't, there's not enough settings. Well, there are settings, but I like the settings on this one more. It's more, going more in depth. Temperature, how hot you want your hot end. Now the cool thing about this program is PLA is really finicky. The higher you go, you want a higher temperature because eventually your nozzle will clog and then you're going to fail your print. So at a certain layer, you can then add a higher temperature. So you have a lower temperature on the bottom and then higher temperature to keep the flow going correctly. And we'll go more into, there's an issue with the composite materials, how they destroy nozzles. The more you send material through, the composite particles that are in the ABS, everything is either ABS or PLA with stuff mixed into it. All those particles will then build up into a big clump in your nozzle, and then your nozzle is destroyed. Either you gotta go put a torch to it and clean it out, or throw it out and get a new one, or drill it out. So cooling of your fan speed, you can change your fan, add different layers. Here's G code. If you want different settings, I could go more in depth on that if we want to. It's up to you guys. I'm still learning it myself. G code.
Maybe just a quick rundown about what it is.
Alright, G code is machining code. It's the same code that they use on CNC mills, lathes. This pretty much tells it's a control code for running your machine. So just like a robot will have its code, move your arm X degrees, move your grasps to a width of X millimeters. This will tell your different your different stepper motors. All these 3D printers use stepper motors. CNCs use optical DC motors, which is more, if you talk to Dr. Mazer, it's more fine-tuned. So it'll tell your stepper motor how many steps to take to bring your head to this distance. Tells your stepper motor in your nozzle how many revolutions or how many steps it take to extrude this amount out or in, and it tells how to print your part. Here's different scripts if you want to go online and bring in scripts to add on to your G code. Here's your speeds, your filament densities and stuff. This one you can actually put in your filament density. In advance, I really don't touch this stuff. So here is our block. We wanted to put a raft on it and a brim. So like I said before, a brim is a little outer perimeter and the raft is a little base that it prints on. So we're going to OK this and we're going to prepare to print. Wow, look at that. We actually can see, we have color coded everything. So here is our brim. This purple line going around the part. Does a couple of laps to make sure your filament is coming out of your nozzle the way you want it. So here's your first layer. You got your brim, and then you have your raft printing. So your raft will print its perimeter, and then it'll do this zigzag pattern, really big, wide zigzag pattern, because you don't want to use too much filament. So it does X amount of patterns before you do its final top layer, which is a very fine layer. Does it X amount of times, and then it finally starts printing your part on top of that. And you can see as I go, you printed out the bottom. So that's your bottom thickness, and now you're coming up, that's your infill in the middle. Cuts down time if you have a smaller fill, obviously. And then when you reach the top again, it makes the top layer. So now we're going to go back to the preview mode. We're going to get rid of this 1-inch cube. We're going to bring in that rocket, and we're going to show some. Hold on, things under what the struts look like. Support material. Here we go. Here's our rocket. Prepare to print. Oh, whoops. Hold on. Part so complex, just crashed. Not really. Give it a little bit. I'll respond again. Sorry guys, my computer's been acting slow lately.
Is there a setting so you can put different densities of the plastic in different areas? Say, instead of doing a 45% density or whatever, 50% fill, could you say maybe half and half or something like
What do you mean?
So
I'd say this layer, this amount of material, the whole thing, we have a 70%, then 50%, then 25%.
Is that just too?
You broke it.
I broke it. It's broken, guys. Sorry.
That's a good question.
That is a good question. So we go to infill. This program will not do it, but I'm sure there's a program out there. It's easy. All it's doing is manipulating the G code. It's manipulating the slicing software. So yes, somewhere out there is a program that will allow you to do that. I don't see why not this one won't do it, but usually if you're making a part, it's usually uniform density. And then if you're making assembly, you print out multiple things. So we're going to prepare to print again, and now we're going to see under each of these fins, if the angle is correct, a support. And once again, it doesn't like it. Oh, hold on. No, the angle's fine. We're going to get rid of this and bring in one of my spaceships, one of my games. We're going to click on it, and then we're going to change this up. We're going to make it larger. Let's add a 0. So here's a spaceship. So we're going to prepare to print. And you see all this gray material underneath? This is your support. It's strong enough to help you print, but then you squeeze it and it snaps off in certain areas and comes off easily. And all of these red lines, that's your nozzle moving around. So you want to retract the filament up so you don't have a little wire going across. Now, usually you don't want I said you can sand those off. It's not pretty when you look at it until you make it all clean. So that's this material. Let's try to see if we could print something on the M3D. So you all